June 6, 1944. The morning sky over Normandy erupted with a sound unlike anything the German Wehrmacht had encountered before. Oberst Heinrich Müller pressed his field glasses against his face, his hands trembling not from fear, but from sheer disbelief. Through the smoke and chaos of the Allied invasion, he witnessed something that defied every principle of artillery warfare he had learned at the Kriegsschule in Dresden. American trucks, ordinary canvas-covered cargo vehicles, were unleashing devastating salvos of rockets that screamed through the air like banshees, transforming entire German defensive positions into infernos within seconds. The weapon responsible for Müller's astonishment was the T-34 Calliope, and it represented a revolution in mobile firepower that the Germans, despite their vaunted engineering prowess, had never anticipated. While the Third Reich had invested heavily in complex rocket programs like the Nebelwerfer, the Americans had achieved something far more practical. They had married the M4 Sherman tank with 60 4.5-inch rocket tubes mounted above the turret, creating a mobile artillery piece that could deliver devastating firepower and then vanish before counter-battery fire could respond. But the Calliope was merely the beginning of America's rocket artillery transformation. The genesis of this innovation traced back to the spring of 1943, when American military planners recognized a critical gap in their arsenal. Major General Jacob Devers, commanding the European Theater of Operations United States Army, had observed the psychological and physical impact of Soviet Katyusha rocket systems on the Eastern Front. Unlike traditional artillery, which fired shells in measured sequences, rocket artillery could blanket an area with explosives in mere seconds, creating shock and devastation that paralyzed enemy units. According to military historians at the U.S. Army Heritage and Education Center, Devers pushed for an American equivalent that could be deployed rapidly and maintained by ordinary mechanics rather than specialized technicians. The solution emerged from an unlikely source: the Ordnance Department's collaboration with civilian engineers who understood that simplicity, not sophistication, would win this particular war. They examined the standard 2.5-ton cargo truck, the workhorse of American logistics, and recognized its potential as a weapons platform. The vehicle, affectionately known as the Deuce and a Half, was already being produced in massive quantities, maintained by thousands of trained mechanics, and could navigate the same roads as supply convoys. Why not transform it into a weapon? Captain Robert Morrison, an ordnance officer stationed at Aberdeen Proving Ground in Maryland, supervised the initial experiments. His team mounted salvaged aircraft rockets onto truck beds, creating crude but functional launchers. The first tests in August of 1943 produced mixed results. Rockets occasionally misfired, and the recoil threatened to flip lighter vehicles, but Morrison's team persisted. They reinforced truck frames, developed stabilizing mechanisms, and created aiming systems that allowed crews to fire entire salvos without leaving their vehicles. Within months, they had transformed ordinary trucks into mobile rocket batteries that could devastate targets and relocate before enemy observers could even calculate their position. November 20th, 1943. Engineers at the Rock Island Arsenal in Illinois gathered around a modified GMC CCKW truck that would change the nature of mobile warfare. Colonel James Cummings stood beside the vehicle, watching as technicians made final adjustments to the wooden launching frames mounted on its cargo bed. These frames, constructed from common lumber and steel brackets, held 24 M8 rockets in 2 rows of 12. The entire system cost less than $500 to produce, yet it would prove more tactically valuable than artillery pieces costing tens of thousands. The weapon system received its official designation, the T-27 Multiple Rocket Launcher, though soldiers would soon christen it with a more colorful name. The M8 rocket itself was a remarkably simple device, measuring 4.5 inches in diameter and 4.5 feet in length, weighing 38 pounds including its high explosive warhead. Unlike German rockets that required careful handling and specialized training, the M8 could be loaded by any soldier with basic instruction. The rocket used a simple fin-stabilized design that sacrificed pinpoint accuracy for rapid deployment and devastating area saturation. Lieutenant Colonel Samuel Hogan, an artillery officer who had witnessed German Nebelwerfer attacks in North Africa, immediately grasped the weapon's potential. The Nebelwerfer, despite its impressive range and payload, suffered from critical limitations. It required a dedicated crew, took precious minutes to reload, and its distinctive smoke trail revealed its position to enemy counter-battery fire. The American truck-mounted system, by contrast, could fire its entire complement of rockets in less than 10 seconds, then drive away before German artillery spotters could even radio coordinates to their gun batteries. The Ordnance Department accelerated production throughout the winter of 1943 into 1944. Assembly lines in Detroit, Chicago, and Philadelphia began modifying trucks straight off production lines. Workers welded steel frameworks onto truck beds, installed electrical firing systems, and trained crews in loading procedures. The beauty of the system lay in its maintenance simplicity. If a launcher frame was damaged, any carpenter could rebuild it from standard lumber. If the electrical firing system failed, crews could ignite rockets manually using a trigger mechanism that looked remarkably like a large cigarette lighter. February 14, 1944, the first complete rocket launcher batteries assembled at Camp Polk, Louisiana, for field trials. Major Douglas Fairbanks, Jr., the famous actor serving in the Naval Reserve, observed these trials as part of his liaison duties with Army Ground Forces. He watched crews load, aim, and fire complete salvos in under 3 minutes, a pace that would have been impossible with conventional artillery. The psychological effect was immediately apparent. Even hardened soldiers who understood these were practice rounds flinched at the sound of 24 rockets launching simultaneously, their collective roar drowning out all other battlefield noise. German intelligence, meanwhile, remained focused on tracking American heavy artillery and tank production. Their agents in neutral countries dutifully reported on M7 Priest self-propelled howitzers and new Sherman variants, but they missed entirely the modification of thousands of standard cargo trucks into rocket launchers. This intelligence failure would prove catastrophic once Allied forces landed in France. The Germans had developed comprehensive tactics for dealing with conventional artillery, from counter-battery fire to infantry assault techniques. But nothing in their doctrine prepared them for weapons that could appear anywhere a truck could drive, unleash hell, and vanish within minutes. June 8, 1944, just 2 days after the Normandy landings, Sergeant William Harrison of the 413th Armored Field Artillery Battalion steered his GMC truck through the muddy roads behind Omaha Beach. Behind him, 3 more trucks carrying T-27 rocket launchers followed in careful spacing. They had landed that morning, and already they had received their first fire mission. German forces were counterattacking near St. Lo, and conventional artillery units were fully engaged elsewhere. Harrison's battery would provide the fire support. The target coordinates indicated a German assembly area approximately 4,000 yards distant, well within the M8 rocket's maximum range of 4,200 yards. Harrison positioned his truck behind a hedgerow, one of the countless natural barriers that divided French farmland and would make the Battle of Normandy so brutally difficult. His crew, consisting of just 3 men besides himself, jumped down and began making calculations. Unlike traditional artillery that required complex trigonometry and precise gun laying, the rocket launchers needed only rough azimuth and elevation settings. The rocket's inherent inaccuracy meant precision was impossible anyway, so crews aimed for area effects rather than pinpoint strikes. Elevation 12 degrees, traverse left 15, Harrison called out. Private James Murphy adjusted the truck's launcher frame using a simple hand crank mechanism. The entire aiming process took less than 90 seconds. Harrison connected the firing cable, checked that all safety pins had been removed from the rockets, and radioed his battery commander that they were ready. The order came immediately. Fire when ready. Harrison squeezed the firing trigger. The electrical current surged through the circuits, igniting the first rocket's propellant. Before the first rocket had traveled 50 yards, the second ignited, then the third, until all 24 rockets were airborne. The truck rocked violently on its suspension despite the stabilizing jacks deployed beneath it. Smoke engulfed the position, and the sound, that distinctive rippling roar that would become the signature of American rocket artillery, echoed across the Norman countryside. 4 miles away, Hauptmann Friedrich Weber was coordinating the assembly of his Panzer Grenadier Company when the world exploded. The first rocket struck a barn being used as a company headquarters, detonating with a flash that momentarily blinded everyone nearby. Before anyone could react, 23 more rockets slammed into the assembly area, each one delivering a 13-pound high-explosive warhead. In less than 10 seconds, Weber's carefully organized assault formation dissolved into chaos. Vehicles burned, soldiers scattered, and the attack that was supposed to push Allied forces back to the beaches never materialized. According to documentation from the U.S. Army Center of Military History, this engagement represented the first combat use of truck-mounted rocket artillery in the European theater. Its effectiveness exceeded even optimistic projections. German forces, accustomed to the methodical approach of Allied artillery that would fire ranging shots before unleashing full barrages, found themselves utterly unprepared for weapons that delivered maximum violence instantly. There were no warning shots, no time to take cover, just sudden, overwhelming destruction. Harrison's crew didn't wait to observe the results. Within 2 minutes of firing, they had collapsed the stabilizing jacks, started the engine, and were moving to a secondary position half a mile away. When German artillery finally responded 15 minutes later, targeting the original firing position with precision counter-battery fire, they found only empty fields and lingering rocket propellant smoke. June 15, 1944, General Oberst Günther von Kluge summoned his intelligence officers to his headquarters near Caen, demanding explanations for the devastating new weapon that was wreaking havoc on German positions throughout Normandy. The reports from frontline units all described the same phenomenon: sudden rocket barrages appearing from unexpected directions, delivered with such speed that defensive measures proved useless, followed by the mysterious disappearance of the firing units before counter-battery fire could be coordinated. Hauptmann Erich Schneider, an intelligence analyst who had served on the Eastern Front and witnessed Soviet Katyusha attacks, initially assumed the Americans had simply copied the Russian design. But as his team assembled captured rocket fragments and interrogated prisoners, a disturbing picture emerged. The American system wasn't a copy of anything. It was an entirely new approach to mobile artillery that prioritized tactical flexibility over technical sophistication. The rockets themselves were crude by German engineering standards, with wide dispersion patterns and relatively simple propellant systems. Yet this apparent crudeness masked brilliant strategic thinking. "They've turned their logistics advantage into a weapon system," Schneider explained to von Kluge, spreading reconnaissance photographs across the map table. "Every supply truck that enters the combat zone could potentially be a rocket launcher. We cannot distinguish between ammunition transports and artillery units. Our spotters report target coordinates, but by the time our artillery responds, the Americans have moved. It's the Eastern Front nightmare, but worse. At least the Katyushas were distinctive vehicles we could identify." Von Kluge studied the photographs with growing concern. The German military doctrine emphasized precision, concentration of force, and superiority through technological advancement. Their Nebelwerfer systems, while effective, required dedicated crews, specialized vehicles, and careful positioning. The Wehrmacht had invested heavily in training these crews and developing tactics to maximize the Nebelwerfer's capabilities. Now they faced an opponent who had achieved similar, perhaps superior, tactical results using ordinary trucks and simple rockets that required minimal training to operate. July 2, 1944. The situation grew more desperate for German forces as American rocket artillery proliferated throughout the Allied armies. The 27th Armored Field Artillery Battalion reported destroying a German armored column near Carentan using a coordinated strike of 5 rocket launcher trucks. The attack lasted less than 20 seconds, but disabled 4 Panther tanks, destroyed numerous support vehicles, and killed or wounded over 60 soldiers. The German unit preparing to counterattack an American advance found itself combat ineffective without firing a shot in response. Oberstleutnant Hans Fischer, commanding a Panzer battalion, recorded his experiences in a diary that would later be recovered by American forces. His entry from early July captured the psychological impact of facing American rocket artillery. "We have faced Russian artillery, British naval bombardments, and American heavy bombers, but this weapon is different. There is no warning, no crescendo of approaching shells, no time to take cover. One moment you are advancing, coordinating your units, and the next moment hell erupts around you. My men have begun calling it Amerikanischer Donnerwagen, American Thunder Wagon. They fear it more than fighter bombers because at least aircraft you can see and hear approaching. The German military attempted to develop countermeasures. Artillery units received orders to maintain constant surveillance of roads near the front lines, ready to fire at any vehicle that stopped and appeared to be deploying weapons. The Luftwaffe, despite being overwhelmed by Allied air superiority, allocated reconnaissance flights specifically to locate rocket launcher units. Infantry patrols received instructions to engage any suspicious trucks with immediate fire, even if it meant wasting ammunition on ordinary supply vehicles. These countermeasures proved largely ineffective. The Americans had learned from their initial deployments and refined their tactics. Rocket launcher crews now operated in small, dispersed units that could blend seamlessly with regular supply traffic. They positioned their vehicles near natural cover, maintained strict radio silence except during fire missions, and never fired from the same location twice in succession. August 10, 1944. The success of truck-mounted rocket launchers prompted American ordnance officers to expand the program beyond anyone's initial expectations. At the sprawling logistics bases in Southampton, England, modification teams worked around the clock converting standard cargo trucks into rocket launchers. Production had accelerated to the point where entire artillery battalions were being re-equipped with the new weapons, supplementing rather than replacing conventional artillery pieces. Colonel Thomas Hickey, commanding the 402nd Armored Field Artillery Battalion, pioneered new tactical doctrines for employing rocket artillery in combined operations. His battalion participated in Operation Cobra, the breakout from Normandy, where they demonstrated the weapon's versatility in supporting rapid advances. Unlike conventional artillery that required significant time to displace and reposition, rocket launcher trucks could keep pace with advancing armor, provide immediate fire support, and then resume movement without disrupting the attack's momentum. The Ordnance Department continued refining the system based on combat feedback. Engineers developed improved aiming mechanisms that allowed crews to achieve somewhat better accuracy, though the weapon's true value remained in area saturation rather than precision strikes. They experimented with different rocket types, including smoke and illumination rounds that expanded the system's utility beyond pure destructive power. One particularly innovative development was the M16 multiple-gun motor carriage, which mounted 4 50-caliber machine guns and 2 30-caliber machine guns on a half-track chassis. But this proved less practical than continuing to focus on rocket artillery mounted on standard trucks. September 22, 1944. American forces advancing through France encountered increasingly sophisticated German defensive positions, including extensive fortifications around the city of Metz. Traditional artillery struggled to reduce these fortifications without expending enormous quantities of ammunition. Rocket launcher units, however, could deliver concentrated barrages that, while less accurate than conventional artillery, created psychological effects that often proved as valuable as physical destruction. Lieutenant Robert Patterson commanded a rocket launcher platoon supporting the attack on Fort Driant, one of the key fortifications in Metz's defensive ring. His mission was to provide fire support immediately before infantry assaults, suppressing German defenders and forcing them into underground positions. Patterson's 4 trucks positioned themselves at carefully surveyed locations, allowing them to coordinate their fire for maximum effect. When the infantry attack commenced, all 4 trucks fired simultaneously, 96 rockets in approximately 8 seconds, creating a maelstrom of explosions across the fort's outer defenses. German defenders, even those sheltered in concrete bunkers, found the experience overwhelming. Feldwebel Otto Braun, captured after the fort's eventual fall, described the bombardment in his interrogation. "We had weathered artillery barrages before, even heavy naval guns during the Atlantic Wall defense, but nothing prepared us for this. The sound alone was terrifying, not individual shells but a continuous roar like standing beneath a waterfall. The explosions came so fast that we could not distinguish between impacts. When it stopped, we were so disoriented that the American infantry was upon us before we could man our defensive positions properly." The success of rocket artillery in the European theater prompted the War Department to expand production dramatically. Manufacturing facilities in the United States received contracts for thousands of additional launchers. Training programs at artillery schools incorporated rocket launcher tactics into standard curriculum. Field manuals were hastily updated to include procedures for coordinating rocket strikes with conventional artillery and air support. What had begun as an experimental weapon system had become a standard component of American combat power. Meanwhile, the Germans struggled to develop equivalent capabilities. Their industrial capacity, strained by Allied bombing and resource shortages, could not match the American ability to mass-produce simple, effective weapons. German rocket programs continued to focus on sophisticated designs like the Wurfrahmen 40 and various Nebelwerfer variants, weapons that required specialized production facilities and trained crews. October 12, 1944, while the European theater showcased rocket artillery's effectiveness against mobile German forces, the Pacific theater presented entirely different challenges. The island warfare that characterized the fight against Japan involved assaulting heavily fortified positions where defenders occupied caves, bunkers, and prepared defensive works. Major General Roy Geiger, commanding the 3rd Amphibious Corps, recognized that rocket artillery might offer solutions to problems that had plagued previous island assaults. The Battle of Peleliu, which began in mid-September, had demonstrated the horrific costs of reducing fortified positions. Japanese defenders, fighting from interconnected cave systems in the coral ridges, had inflicted severe casualties on American forces despite overwhelming firepower superiority. Naval gunfire and conventional artillery could damage surface structures, but had limited effect on underground positions. General Geiger proposed using truck-mounted rocket launchers, modified for amphibious operations, to saturate defensive areas immediately before infantry assaults. Marine ordnance officers adapted the standard T-27 launcher for Pacific conditions. They reinforced truck frames to handle the rough terrain typical of Pacific islands, added waterproofing for equipment that would likely be exposed to saltwater and tropical conditions, and modified firing mechanisms to function reliably in high humidity. The resulting weapon system maintained the essential simplicity of the European version while addressing specific environmental challenges. November 5, 1944, the 1st Marine Division prepared for future operations by conducting extensive training with rocket launcher units on Pavuvu Island. Colonel Lewis Burwell Fuller, the legendary chesty puller, observed these exercises with particular interest. Fuller, who had commanded a regiment at Peleliu and witnessed the difficulties of reducing fortified positions, saw potential for rocket artillery to reduce casualties in future assaults. His regiment would incorporate rocket launcher platoons into its assault plans for the upcoming campaign. The tactical employment of rocket artillery in the Pacific differed significantly from European operations. Rather than firing and immediately displacing, Pacific launchers would often remain in position for sustained bombardments. Engineers developed firing positions that protected vehicles from counter-battery fire while allowing repeated launches. They created ammunition dumps positioned to allow rapid reloading, recognizing that island assaults would require sustained rather than hit-and-run fire missions. Sergeant Michael O'Brien, commanding a rocket launcher section, participated in pre-invasion bombardments of Japanese positions on various islands throughout late 1944. His experiences highlighted both the weapons' capabilities and limitations in Pacific warfare. Against surface targets, buildings, supply dumps, and light fortifications, the rockets proved devastatingly effective. However, against the deep caves and reinforced bunkers that characterized Japanese defensive positions, rockets had limited direct effect. Their true value emerged in suppressive fire, keeping defenders underground while infantry and engineers moved forward to reduce positions with flamethrowers and demolitions. December 20, 1944, intelligence analysts compiled reports on Japanese reactions to American rocket artillery. Captured documents and prisoner interrogations revealed that Japanese commanders, like their German counterparts, found the weapons psychologically devastating. However, the Japanese military's emphasis on holding positions regardless of casualties meant that psychological effects alone rarely dislodged defenders. Rocket artillery had to be integrated with other weapon systems, flamethrowers, close support aircraft, and direct fire tanks, to achieve desired results. Lieutenant Colonel James Donovan, an artillery officer attached to the 5th Amphibious Corps headquarters, drafted tactical guidelines for employing rocket launchers in future Pacific operations. His recommendations, based on lessons learned from Peleliu and subsequent operations, emphasized concentration of fire on specific identified targets rather than area bombardment. He advocated for close coordination between rocket launcher crews, forward observers, and assault infantry, ensuring that fires could be adjusted based on real-time battlefield conditions. The Pacific Theater's unique challenges also prompted weapon system innovations. Engineers developed launchers that could be mounted on LVTs, landing vehicle tracked, allowing rocket artillery to provide fire support during the actual amphibious assault, rather than waiting until vehicles could be landed. These LVT-mounted launchers, while reducing ammunition capacity, offered immediate fire support capability that proved valuable in the crucial first hours of an assault. January 17, 1945. The Wehrmacht faced its final crisis on both fronts as Allied armies closed in on Germany itself. In the Ardennes, the ambitious German counteroffensive that became known as the Battle of the Bulge had failed, due in part to American artillery's effectiveness in disrupting German supply lines and troop concentrations. Rocket launcher units had played a crucial role in this defense, providing rapid response firepower that blunted German spearheads at critical moments. Captain James MacDonald commanded a composite artillery unit defending near Bastogne during the siege. His command included both conventional howitzers and 3 truck-mounted rocket launchers. When German forces attempted to overrun his position on December 26, 1944, MacDonald's rocket launchers delivered a decisive response. Positioned in a tree line overlooking the German approach route, his trucks fired coordinated salvos that decimated the attacking force. The Germans, expecting preparatory fire followed by a deliberate barrage, instead encountered immediate maximum violence that shattered their assault before it properly began. General Lieutenant Heinrich von Luttwitz, commanding the German forces attacking Bastogne, later acknowledged in interrogation that American artillery, particularly rocket systems, had exceeded German expectations. "We planned for conventional artillery response times, calculated how long we had between when your observers spotted us and when shells would land," he explained. "Your rocket trucks eliminated that calculation. They fired so quickly after being called that we had no time to disperse or take cover. It was like fighting an opponent who could see the future." February 8, 1945. The Red Army's advance into eastern Germany provided Soviet observers their first opportunities to examine American rocket artillery closely. Liaison officers exchanged technical information, and Soviet military analysts expressed surprise at the American approach. The Soviets had developed their Katyusha systems into massive batteries mounted on dedicated military vehicles, emphasizing overwhelming firepower and dramatic visual effect. The American system, by contrast, prioritized flexibility, ease of maintenance, and integration with existing logistics networks. Colonel Ivan Petrov, a Soviet artillery officer assigned to coordinate with American forces, observed rocket launcher operations near the Elbe River. He noted in his reports to Moscow that the American system, while less dramatically impressive than the Katyusha batteries, possessed significant tactical advantages. American launchers could operate independently or in small groups, required minimal specialized support, and could be maintained by ordinary soldiers with basic mechanical knowledge. Most importantly, the Americans had produced thousands of these launchers at relatively low cost, achieving practical results that matched or exceeded Soviet capabilities despite simpler technology. The final months of the European War saw rocket launcher units participating in every major offensive. They supported river crossings, provided fire for urban combat, and delivered suppressive fires during the final advances into Germany. Their versatility and reliability had made them indispensable components of American combat power. Units that had initially viewed rocket launchers as experimental weapons now considered them essential equipment. March 23, 1945, during Operation Plunder, the crossing of the Rhine River, rocket launcher units demonstrated their value in supporting complex amphibious operations. The assault required precise coordination between engineers, infantry, armor, and artillery. Rocket launchers provided immediate suppressive fire against German positions along the east bank, allowing assault boats to cross with reduced casualties. Their ability to deliver concentrated firepower quickly proved especially valuable during the vulnerable period when troops were crossing, but had not yet established strong defensive positions on the far shore. Lieutenant William Stevens commanded a rocket launcher platoon supporting the 79th Infantry Division's crossing. His after-action report described firing 7 complete salvos, 168 rockets, in the space of 15 minutes, far exceeding what any comparable conventional artillery unit could have achieved. The rapidity of fire forced German defenders to remain under cover, reducing effective return fire against exposed American troops. Stevens noted that his crews reloaded and fired so frequently that the truck beds became dangerously hot, requiring water cooling between salvos to prevent ammunition cook-offs. German defenders, by this late stage of the war, had developed some countermeasures. Artillery units with remaining ammunition attempted immediate counter-battery fire against suspected rocket launcher positions. Infantry units with Panzerfaust anti-tank weapons would sometimes engage visible trucks, hoping to destroy launchers before they could fire. However, these measures achieved limited success. The Americans had refined their tactics to minimize exposure, and the sheer number of rocket launcher units made comprehensive defense impossible. April 25, 1945. American and Soviet forces met at the Elbe River, effectively cutting Germany in two. In the Pacific, preparations continued for the invasion of Japan's home islands, an operation expected to require every weapon in the American arsenal, including the now ubiquitous truck-mounted rocket launchers. However, events would soon overtake these plans when atomic weapons brought the war to an abrupt conclusion in August. The final accounting of the rocket artillery program revealed achievements that exceeded even optimistic projections. American forces had deployed over 4,000 rocket launcher trucks across both theaters, from the forests of Europe to the jungles of the Pacific. These weapons had fired hundreds of thousands of rockets, delivered tens of thousands of tons of explosives, and influenced countless tactical engagements. More importantly, they had achieved these results while requiring minimal industrial resources. The entire program's cost was less than a single heavy bomber wing. Major General Bruce Magruder, commanding the artillery school at Fort Sill, Oklahoma, supervised the compilation of lessons learned from rocket artillery employment. His staff analyzed thousands of after-action reports, interviewed hundreds of veterans, and conducted extensive testing to understand what made the system so effective. Their conclusions emphasized factors that went beyond technical specifications: the psychological impact of rapid, concentrated fire, the tactical flexibility of having artillery that could appear anywhere trucks could travel, and the strategic advantages of weapon systems that required minimal specialized support. The German military in its final days could only acknowledge the effectiveness of American rocket artillery. General Oberst Alfred Jodl, signing Germany's unconditional surrender on May 7, 1945, later discussed Allied weapons during his interrogation. Asked what had surprised him most about American military capabilities, Jodl mentioned not tanks or aircraft, but the simple truck-mounted rocket launchers. "You took ordinary vehicles and turned them into weapons of extraordinary effectiveness," he said. "We Germans prided ourselves on engineering excellence, on sophisticated weapons that embodied technical superiority. You defeated us with practical simplicity, weapons that any mechanic could maintain, any soldier could operate, and any truck could carry. It was a lesson in the difference between engineering elegance and military effectiveness." August 15, 1945. Japan's surrender ended World War II, and with it, the immediate need for continued rocket artillery development. However, the system's legacy would extend far beyond the war itself. The concept of mounting rockets on ordinary vehicles influenced military thinking for decades. During the Korean War, American forces again deployed truck-mounted rocket systems, now called the T-66, and later the M91. These weapons proved their value in a different type of warfare, providing fire support in mountainous terrain where conventional artillery struggled. The true revolution, however, lay not in the weapons themselves, but in the tactical and strategic thinking they represented. American military planners had recognized that in modern warfare, adaptability and rapid deployment often mattered more than technical sophistication. A simple weapon available everywhere proved more valuable than an elegant weapon available nowhere. This insight would influence American military procurement for generations, from the development of the M113 armored personnel carrier to the adaptation of commercial trucks for military use in later conflicts. Sergeant William Harrison, the crew leader who had fired some of the first American rocket artillery shots in Normandy, returned to civilian life in Indianapolis, where he worked as a mechanic. Years later, interviewed about his wartime experiences, he reflected on the weapon that had made him and thousands like him artillery soldiers. "We were just truck drivers who happened to carry rockets. That was the genius of it. The Army didn't need to train us to be artillerymen, didn't need to teach us to maintain complex equipment. They gave us trucks, which we already knew, and rockets, which any fool could load and fire. The Germans kept waiting for us to do something complicated, something that matched their expectations of how artillery worked. We just kept it simple, and simple won." The story of American rocket artillery during World War II demonstrates a fundamental truth about military innovation. Sometimes the most effective solution is not the most sophisticated one. By transforming ordinary trucks into devastating weapons platforms, American engineers and soldiers created a system that combined tactical flexibility, strategic economy, and psychological impact in ways that more elegant German weapons never achieved. The Germans couldn't believe America had turned trucks into rocket artillery, and by the time they understood the full implications of this simple innovation, the war had already turned irreversibly against them. The thunder from those ordinary American trucks had announced a new era in warfare, where practical ingenuity would triumph over technical complexity.